Time to share my screen. Well, I don't need to share my screen. I need to share my camera. Hello, everybody, and welcome to another episode of What's He Gonna Do Today? Today, we're going to learn about lists. And you notice I got my camera straightened out. Can I get a woohoo for that? I got a woohoo from Galen. Okay. So, let me make it look pretty. So, as you can see, we've jumped to the NIAF book. We've gotten out of the Gaddis book. And there's some things like, even right now, this introduction to lists is not in the Gaddis book. It's in the NIAF book. And when you're reading and looking over the NIAF book, you're going to find out it's a little more technical than the other books. Okay. Did everybody get the thing about watching the record, right? We're all good? You're in? Okay. So what we're going to talk about today is a basis for a lot of what's going to go on the rest of the course. And it's going to be one of two ways to do things, and we're slowly going to build on it. But for today, we're going to start out with what seems to be simple, but we're going to develop a pattern for learning new data types as we go through. So the data type we're going to create today is one called a list. All right, it's going to be an abstract data type. It's one that we're creating. And what makes it a data type is just like in a class. You know, I create something, and then I'm going to create a bunch of functions that will work with whatever this data type is I'm creating. Okay. So today we're going to talk about a list, and as you can see, I've made some notes ahead of time, and it is in fact homogeneous, which means all the elements are the same. They're either all test scores, they're all names, they're all temperatures of a day for the last 31 days. They're all the same data type, and they're all related somehow. Okay. One of the things we know, if I want to work with a list, it has to have a finite length. And you start to look at the picture I have down a little bit, right about there, and the word has already come to your mind. The best place to store all of this data type is going to be an array. It's not something I could put in a struct because that would be too messy. But for now, it's just going to be in an array. Okay, it's sequential. There aren't any blanks in the middle. You know, I have a first and it goes ... right to the last, which means I may have some empty spots at the end, and that's fine. But one of the things we have to do is make sure we have enough space to store all the data we need. A lot of you had me for 121, and I had you open a file of data. You went through and did a count of how many data elements there were. Then you initialized the array, and that was great because we didn't waste any memory. We didn't come up short with memory. We knew exactly what we needed. Now, a list is going to be a little bit different because I may get new data, or I might want to delete data out of the list. So when we're working with the list, I need to make sure that I'm pretty good with memory. If I want to do a class like all of your final grades, you know, I can come up with a safe size, not 4,000, because there's not going to be 4,000 students in this class, but something a little bit smaller. So this is our big concern right here. We don't want to waste any memory at all. Okay, so far so good. So what are we going to do? We're going to create a class to handle this. And what is it we're handling? Well, we're going to handle this array. And it's known as a static array because the size doesn't change. What's the word that goes along with static, but it's like its opposite, where the size does change?
Dynamic.
Dynamic, right? So another word that we're going to get into in a couple of classes from now is dealing with something that's dynamic, which means its size can change. It can shrink or expand as needed, and memory is not an issue. It's not a concern. Okay. So if I want to get ready and I want to create a class to handle this array, so I'm going to have an array, some things, some functions that I might need to go along with it. For example, I might need a constructor. And what would happen in the constructor? I would create the array. So one of the things that I would have in my class is a field definition for the array. What's another field definition I might have up in my privates? Well, I may have a constant for the size of the array. What's something else I might have up in there? Well, if I start putting numbers in 1, 2, and 3, what might I want to know? Maria, your lips are moving.
The data type?
Yeah, the size, the data size. Some way to keep track of my size, okay? I would need a way to check to see if it's empty. And if we just created what we said a moment ago, a variable to keep track of the number of elements, then this function to check to see if it's empty would basically see if that number of elements was 0 or not. I might want to insert something into the list. So I might have some numbers in here, 2, 4, 6, 8, 14. And all of a sudden, I want to put in the number whatever, wherever. So I might have to create an insert. Now, in this list, I don't necessarily know if it's sorted. So when I'm doing this insert, I'm going to need to know what number I want to insert and where I want to insert. Now, things that might be happening. If I inserted in this position, what about what was here and everything to the right? We're gonna have to do some shifting over. Okay? Same with delete. Say I want to delete a number and I come in and find the number I want to delete. Delete that, shift everything to the left kind of deal. So if I have an array of 2, 4, 6, and 8, my size would be 4, and that's all I'm worrying about. So if I delete 6 and move 8 over, do I necessarily have to delete this 8? No, because I'm only worrying about my size. 2, 4, and 8 would be in here if I deleted the 6. Okay, so that my size is going to become pretty important. Another thing I could do with this list, along with inserting something and deleting something, is to traverse through the list. I may traverse through because I'm searching to see if the number 6 is in there. Or I might want to print everything out. I may be doing a copy. I may be doing a whole bunch of different things. But this concept of traverse is one that we're going to have to keep in mind. Questions? So far, so good? Okay. Well, if I had asked you to do empty, again, we just talked about it a moment ago. I need to create a variable like my size, or whatever you want to call it. We're going to go with my size for a reason. And so my size, if it's 0, then I would return a Boolean true or false. So this empty function, I think it's going to be of type Boolean. Okay. Traverse, I'm going to go 0 to size, -1. That has me traversing through. But I might want to just do from 0 to my size so that I don't possibly hit any extra garbage out on the end. Lots of different ways in which I could handle my list. That's something that would be a discussion. Insert. Let me fix my camera. Insert. So I'd like to get ready and write a function for insert, but I think I'm going to do the pseudocode. Now, this is a process, and I could just turn you loose and, you would go all over the place, basically. But if I'm going to insert into an array, all right, let's see. I'm going to create one. Shooby-dooby-doo, doo-dooby-dooby. What's my size? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go with a nice 10. Okay. So I have an array of size 10. And I'm going to put some numbers in. 8, 4, 3, 9, 7, 2. And that's it. So if I got ready to insert, what I want to start to train you to do is think about all possibilities first. And all of a sudden I'm going, wait a minute, my first possibility would be is, are there any numbers in there at all? Because if there aren't any numbers in, where would I put the number I'm going to insert? I mean, it would have to go like in the first spot. So down the road, when you're writing insert, and again, today's insert's a little different than what we're going to see down the road. But for today, we don't need to consider it. But down the road, we're going to have to start thinking about, is this bad boy empty or not? Okay. So insert. Give me locations that would be of interest for inserting something.
The beginning, middle, and end.
Yeah. Well, we'd have to start to take consideration of, what if I'm inserting in the beginning? Where's another location that would be of concern? Somewhere in the middle, right? Somewhere in the middle and somewhere at the end. Okay? And we also talked about if it's empty. So as we start to do these data types for the next couple of weeks, as soon as you start talking about inserting into a list, these are some things that I want you to be considering. Now, the insert you're going to write today is just going to be to insert at a position. So you're going to be writing something today. Now, what am I looking at? If I want to insert at a position, and again, beginning, middle, end, some of these may take care of other ones when I get ready and write them. But for today, I want to insert a number at a location. And once I do, I'm going to have to do a shift. Something to consider later is we may have another function called is full. Because if my list is full and it's static, I can't insert a new number. Okay, so I want to insert. Let's, for today, this is just for this assignment that we're going to be working on. I'd like to insert. So when I insert, I'm going to be given a position and a number in my parameter list. Okay, so let's decide. Say I want to insert something at position 3. What kind of algorithm would I need to work through this? So again, this is just a practice group project we're going to be doing in a few moments, but I want to lay out how this particular insert's going to work. So we're going to assume that it's going to go in. We're not even going to worry if it's full. We're just going to do the simple inserting. All right. So we have the size of our array is a constant. We'll call size 10. And let's have another one called num elements. Okay, and at this point, 2, 4, 6. The number of elements is 6. Throughout this course, we're going to do several group projects. And one of the things you're going to find is when we break up and you go do this and you go do that, what's going to become real important is the naming, the size, the number of elements, because you're going to be disjointed working on pieces, but you're going to have to come back together to put the pieces back together. And one of the places you're going to mess up is num elements. What do we want to call this? Num array. So as a group, you start to decide, hey, some of these things we need to lay out ahead of time and start to be consistent with. All right, so all I want to do in insert today is assume there are numbers and I want to insert into the list. So let's say I have a position and I want to put in position 4 the number 11. Again, so I'm doing some testing. I haven't sat down to type because I wouldn't have gotten anywhere. So somebody tell me what to do with the number 4 or position 4, 11. So basically 11 is going to go here and these two are going to get shifted. What do you got?
You want to shift everything above position or at position 4 and above. You want to shift it right one position.
Exactly. So I need an array. Well, oh, no, wait, I got another thing to discuss. So sooner or later, you folks are going to start to jump in. Where is position 4? What is at position 4 right now?
7.
7? 9? Pick one. What is the 4th position? Now, our array subscript is 3 in the 4th position. So again, these are communication things that you need to lay out. I'm thinking if I'm looking at an array, this is the 1st, 2nd, 3rd, and 4th position. So I want to put that right there. So I'm going to need a loop for, and it looks like I need to go.
Well, couldn't you, like, in your function, they pass in the argument position, couldn't you, like, add 1 to that to avoid confusion?
And again, this is going to all be dictated later. So what you're saying is when the 4 gets passed in, you said add 1. Would you mean subtract 1?
Well, like if, yeah, I'm sorry, subtract 1. You're right.
Subtract
So I was saying
1.
inside the function, you could reassign that, like by just subtracting 1. So that point it matches the
Okay.
position.
So
right?
we'd like to have a loop from position -1 to num elements. Right. And again, this is one of the things where whiteboards, if we were, and this is why I don't like this class online. I like us in the classroom. Whiteboards would be great at this point because we could just be writing all over them to figure out what we're going to do. So this is going to give me 3 up to 6. So I want 3, 4, 5. I don't want num elements, do I? What do I want? Num elements -1. Okay, so you see where we're going here. This is a lot more thinking than typing, and that's what this course is going to become. A lot more thinking. All right, now wait a minute. I need to back up a second. If I want to shift, how am I shifting? Which one would you shift? Go ahead, Conrad.
I was going to say, you're going to have to start at the end and shift because you're shifting everything right.
Yeah.
So in order to not overwrite already inserted information, you're going to have to start at the right and shift it right one space.
Yeah, so all of a sudden, my num elements -1 to pause, I might be going, I need to cross that out. That's going to be, wait a minute, I want this to go to this guy to go to the 6th spot. So again, there's a whole lot of jockeying that I want to be doing on paper and drawing. I may even want to go something like this. So now I want 5 to go to 6, 4 to go to 5, and 3 to go to 4. So all of a sudden, I wrote down the subscripts that I want to have. So you see where we're developing a plan on how to put this together. And this is just to do the shift. But again, I feel good because I'm writing these numbers. So now I either need a loop from 5, 4, 3 or 6, 5, 4. Which loop would you rather? Go ahead. Go ahead.
Go ahead, Joe.
Okay, I was just saying, you could also put it like a temp number, so like it can save the 4th position and then put the whatever we want to put it, and then basically instead of like doing backwards, we can also like keep the one we already had and then put a temp number pretty much.
I think you might need 2 temps. Would you go with that? So I want to move 9 out. So 9 sitting here. I moved the new number in, but now you need to move 7 to a different temp, and then that back there, and then 7 over to that temp, and this up to there. Yeah.
Yeah. So, again, so that way, we don't have to worry about how many, whatever, like how many numbers we have at the end.
Right. A thing there would be drawing it to make sure it works to start.
Yeah.
Okay. So for today and today only, this is how insert's going to work. We're going to assume insert is going into somewhere in the middle. So we have to create this loop kind of deal to be able to put a new number in. And again, we're not worrying about all of these other inserts today. I just want a simple function to insert like we were just talking about a minute ago. And notice how we even created some of our own test data. Okay, we created some test data. One of the things you may have to do early on is, you know, get some numbers in this position. You know, you may have to fill the array with 8, 4, 3, doing that type of insert as well. And then we can do other inserts which do the shifts.
Couldn't you do like your for loop where you start out being equal to num6 and just decrement it working backwards?
Yes.
Instead of incrementing, you
Yes.
decrement, work backwards, and add 1 to the subscript to move it to the right?
Correct. And again, I said we could either do 6, 5, 4 and, you know, subtract 1 with the subscript, or do 5, 4, 3 and then add 1 with the subscript to get what we need. But the first one was the 6th position gets what was in the 5th. Then the 5th gets what was in the 4th. The 4th gets what was in the 3rd. And then after my loop, I would now insert new number. Okay. Oh, that was another thing. When we get back over here, we may have to work this display pretty hard just to keep track of what we're doing. It's great that we can keep throwing display out there. All right. Again, for today only, I'm going to have Shaka Khan, da-da-da-da, same kind of deal. 1 is 8, 4, 3, 9, 7, 2, on and on and on. And I'm going to write a delete. And again, this delete is just specific to what we're doing today. I'd like to delete, well, what are we going to be passing in? I think in delete, I'm going to pass in a position, and I want to delete in that position. So again, are we definitely set on position 1, 2, 3, and 4, even though the subscripts are 0, 1, and so on? And we decided yes, that the position is that position in the array. So if I wanted to delete, I think I have the same kind of thing going on where if I delete position 3, I need to go and move 9 over, move 7 over, move 2 over. What else would need to change in this guy and this guy? So I have these two parameters, pause and number, but is there something else that would change if I added a number into that? Take a guess.
It would be a number element.
Yeah, the number of elements, right. So one of the other things you need to figure out how you're going to do it is when I insert, number of elements is going to have to be increased. Now, do you do that after insert is called? Do you do that inside of insert? Where are you going to be doing it? Okay. And then does it need to be a parameter? Could num elements be something called a static variable? So many ways to deal with all of these. Okay, so you're going to do a group project, and I'm giving you a partial spec file. The reason I say it's a partial one is I can't find another one for list H that the display simply displays on the screen. The one I'm giving you, you're going to have to doctor up. Right now it displays to a data file. So you can delete all of that off of there and just have a display to a screen. And I'll show you that in a minute. Once that's done, we're going to have to create an implementation file and a demo file. So as group leader, I'm now thinking, all right, so I have a demo file and I'm going to need to get certain students on the demo file. If I go back to my spec file, as I said, I need display to be cleaned up. I don't want it to send it to a data file. I just want it to display. So that's going to have to be cleaned up. when I get to my .cpp file, you know, I'm looking at things that need to be written like a constructor. Well, the other thing we need to talk about is, are there any variables that I need to include? Any extra fields, and what are we calling them? And then I need a constructor, which is kind of easy to write once we know the name. I'm going to have somebody do a quick, well, we don't need is empty for today. I think our big ones are going to be insert, delete, and display. All right. So I'm going to start assigning some roles to people. And actually, I should give somebody else the role of lead so they can bounce around and make everything be coordinated. I did enable sharing screen, so whoever the group leader will be able to handle a lot of that. Now, one thing I want to mention real quick, you're going to see, is something called type def. There's going to be this line that says type def int element type. Now, what's really cool about this is wherever I have element type inside of my program, I know that's the data type int. So what happens if I wrote all this and said, oh, I'd now like to make my list a list of doubles? Well, if I'm using element type as my data type name, all I would have to do is change int to double. And I could reuse this for a list of doubles and not have to rewrite anything else. Okay, and so you're going to see this type diff, and that's what it is. All right, so
I had a question about that. Is that like a declaration for a list data type something, or
no? It's just naming.
Naming the list?
It's naming element type as the word int. So wherever element type shows up, that can be replaced by int, because I'm going to declare that in the beginning of my program.
Okay.
All right. So now I need to check the participant list, and somebody probably came late. Was it Dylan or was it Victorici? Or neither?
It was me.
It was Dylan came late. All right. Victorici is a no-show today. What is going on with that? So looking at the list, and I need to, so what do we have? We have 13 people. I need one to modify here, maybe two here, one person to be the lead, and then I'm going to start to fill in some names down there. So does anybody have any that they are like, yeah, okay, yeah. But we need to declare some variables over there. The faster this part goes, the more time you get to work on this. No, nobody's jumping out and saying, hey, yeah. All right, so then I'm going to go in order. Let's see who we have up top. I'm going to put Alex and Brendan working on cleaning up the .h file. What I mean by that is you need to see if there are extra variables we need to put in. And once you get them, you have to report out to the group, okay? But you're also going to clean up the
Professor, is that me? Is Alex me, Alan? Or is it, I don't know, is there an Alex?
It is Alan. I'm sorry.
Okay. I was just making sure that's me.
Class.
Yeah.
Yeah, that's how I roll. Okay. The .cpp file. I'm going to put Cassius on, getting ready to get all this coordinated. Oh, one of the things I'm thinking of is, where do we send these files once we start to write them? So Cassius, you may be working with Alan and Brendan, okay, and watching what they're doing so you can get ready and start to lay out the CPP file so that when people send you the function, each of these functions below, you can put them in the .cpp file. And just like Alan and Brendan, when you're done, you can go and jump in and see who else can work. See, it's nice in the classroom because you can move around to all different places in the classroom. All right, so what do I have next? The constructor. I'm going to leave the constructor up to Cassius as part of the .cpp file, okay? So Cassius, you okay with everything that's going on there?
Yep.
All right. So who do I have next? Conrad and Dylan. You're going to do insert. Working together. And if you want, I can put you in a breakout room. Who do I have now? Galen and Jill. You're going to work on that delete. Okay? Long, you're going to do the display, but you're going to have to wait and work with maybe Alan and Brendan and Cassius to see, what the heading will be. Well, maybe we all need some headings here. Maybe there's a whole lot more we could write down. So Long's on display. The demo, I'm going to put Maria and Mark. And Matt. I don't think we need a lead. I think we can jump all around. So I have Rashawn, and I'm going to put Rashawn down with insert as well. And I'm going to put Giannis on delete because I think they're the ones that are going to be the toughest. Questions? Now, your .h file can be found on the D2L page, okay? And I'm going to turn you loose, and I think I'm going to make a couple of breakout rooms so you folks can start to put together what you need to put together. So even when you're done with insert and delete and display, you might come back to the main room and talk to Cassius, Allen, and Brendan about what's in the .h and the .cpp file. And
Yeah, I was gonna say,
right, go ahead.
don't we need to know, like, if we're creating the .h file, like what's going into the functions for like the headers? As far as
the .h file, you're going to go through right now and clean up the display, just so it's kind of set up. Then you guys are going to jump in here with Cassius and start creating the .cpp file. These folks, when they're done, they're going to send you the prototype or the whole body so that you can put the prototype in the .h and the body in .cpp. So we have a whole bunch of inner working parts. Just like these folks are going to lay out the demo, but once they come back and find out the names of what each of these are, well, why don't we do that right now? Why don't we come up with our functions? So the constructor is going to be a constructor, right? So I'm back in the .h file that Alan and Brendan have. And, so let's see, we have insert. Give me a function heading for insert. Give me a function heading for delete. Give me a function heading for display. Data type. Is it returning anything? Or is it void? I'll tell you, this display is void. Delete.
I mean, it could be void if it's an array because it's passed by reference, right?
And again, our friends in the H file, .h file, they kind of, I think these are all void, right? What would be passing into delete?
The position number
A
of the
position.
array.
Yeah. What do we want to pass into insert? Int pos, position, int num kind of deal. Display. Nothing really going on in display.
Should we use element type instead of int?
Yeah.
Or are we just doing int?
For this number, right, we're going to make this element type. That way, everything is set up for me or, for the user to change the class from int to something else. Now, you're going to see a bunch of this in the .h file.
Oh, okay.
So hopefully, you all go get the .h file right away. And the one thing, again, as I said, is the display is, so from lines 61 on, delete that and get a prototype just for display.
In the .h file, the delete function is also called erase.
I'm sorry,
Instead of delete.
I missed part of what you said. Say again,
Uh,
please.
in the in the list.h file, the
Yeah.
delete function is called erase.
Erase. Okay.
And the insert function has the argument switched.
Okay. Now, is all of this important discussion to have even before we begin? I think
Yeah.
so.
Gotta match
So
up.
these two are switched. We got stuff going on. So yeah, it would help to look at the .h file. Now, I think we're going to need 2 more fields in the .h file. What do you want to call those? So right now, all that's there is that type def and the capacity. It's kind of a small array. But what do we need? We're going to need, where are my .h people?
Um,
We're going to need an array declaration. We'll just call it num array. What else are we going to need? Num elements. Okay.
and then we also have a constructor as well.
Right. And then the constructor is going to go in here. And like I said, empty is in there, but we don't need it. We can delete that out for what we're doing today. Okay. I'm going to create a couple of breakout rooms, but I can't while I'm recording. So I'm now going to end the recording, and we're going to be good to go from there. So I need to close this. I need to